In this video, I want to look at record and enum constructors in more detail. I'll continue using the constructors project from the previous video. I'll create a record and call it person. And include two strings, a name and a date of birth, DOB. As you know, this is all we need to have an operational class whose fields are final. A constructor is inserted by the compiler when it generates the bytecode or class file. It takes the same arguments in the same order as those described in the person record. This constructor is called the canonical constructor. Notice that if I want to generate a constructor, IntelliJ wants me to select from one of three options. Record constructors come in three flavors. The canonical or long constructor is the implicitly generated constructor. You can explicitly declare your own, which means the implicit one won't get generated. If you do declare your own, then you must make sure fields all get assigned a value. The custom constructor is just an overloaded constructor. It must explicitly call the canonical constructor as its first statement. The compact or short constructor is a special kind of constructor used only on records. It's a succinct way of explicitly declaring a canonical constructor. Okay, so let's see what we can and can't do with these. Getting back to my code, I'm going to generate the canonical constructor. If this is all you're going to do, you don't need to generate it, but maybe you want to do some transformations or validation before the assignments. In my case, I want to replace any dashes in my DOB argument with forward slashes before assigning this value to my DOB field. To test this out, I'll create an instance of this record in the main method and print that out. I'll pass Joe as the name and a date of birth string with some dashes. Running this code, I get the default string printed for a record, the toString method being another implicitly generated method. Getting back to the record, so what happens if I don't actually assign a value to the DOB field in this canonical constructor? I'll comment out that second line in the constructor. IntelliJ flags that parameter DOB in the record parameter list as having a problem. Hovering over that, it reads, record component DOB might not be initialized in canonical constructor. Maybe I could try an instance initializer to set it. As mentioned in the last video, an instance initializer starts with a block of code at the class level. Here, I'll try to assign a string literal to the DOB field. Now I've got a different problem, and that's because instance initializers aren't allowed in records. The only place to make field assignments is in this canonical constructor. Let me undo those last two changes. Let's say that now I want to trim this string next, and I'll just reassign this value back to the DOB field. This isn't permitted either because all fields on a record are final, so I can't do that. I'll undo that, removing that extra statement. I'll generate another constructor. Note that the three options for constructors do not pop up here. For now, I'll push the Select None button and we'll explain why we don't get three options later in this video. I'll pass a person argument to this constructor. I want this to be a copy constructor, in other words. Okay, there's another problem, and it's that a non-canonical record constructor like this one must delegate to another constructor. I'll do that, passing name from the person argument and the DOB as well. Going back to the main class, I'll set up a test case in the main method. I'll create a new local variable, JoeCopy, and assign that a new instance of person, passing my Joe variable to that constructor. I'll print this JoeCopy, running that. You can see this works, and I've got a copy of Joe's data in my new variable. Getting back to my person record, you probably noticed what happened when I created that second constructor. Let's see what happens when I try to generate another constructor. I don't have the three choices I had before. I now don't have the option to create a compact or canonical constructor. I can only generate a custom constructor. I'll close that pop-up without generating anything. What happened to my other options? Let me comment out that first constructor, the explicit canonical constructor. Now I'll press Alt Insert again. All my options are back, so why is this? When you declare an explicit canonical constructor, you can't create another constructor. You also can't create a compact constructor since it's intertwined with the implicitly created constructor. In this case, I now want to review the compact constructor, so I'll select that. What do you notice about this constructor? It's missing parentheses, and that's what makes this significant and different. This code gets inserted into the implicit canonical constructor before any final fields are assigned. The advantage of using this compact constructor is that you can just focus on just the custom bit of code and leave the boilerplate code to be generated. Let's say in this case I want to check for null before I replace any dashes in the date of birth variable. I'll throw an illegal argument exception if date of birth is null, otherwise I'll replace the dashes with slashes. Notice here that I'm referring to constructor arguments that aren't explicitly declared by this compact constructor. This constructor has access to all the named arguments of the canonical constructor, so in this case name and DOB. It can reassign values to these argument variables. All of this is occurring without explicitly assigning these values to the instance fields. I never assign these arguments to the fields in other words, but I'm not getting any errors. What happens if I try to do that? Meaning if I actually do the assignment, I get the error message, cannot assign a value to final variable DOB. You can only edit or validate the method arguments because the final fields have yet to be assigned. I'll remove that last statement. I'll next change that last statement, and instead of just DOB, I'll try to execute replace on this .dob. This gives me another error that this .dob might not have been initialized. I can't use the final fields in any of my code here for the reason that this code will get called before they actually get set. I'll undo that too. And now I want to show you a summary of these rules on a slide. The compact constructor is declared with no parentheses, so no arguments. However, it has access to all the arguments of the canonical constructor. Don't confuse the arguments with the instance fields. You can't do assignments to the instance fields in this constructor. The implicit canonical constructor's assignments occur after the execution of this code. You can't have both a compact constructor and an explicit canonical constructor. Okay, I want to pause here a moment to introduce you to another command line tool packaged with Java. This is Java P. It lists class members, by default just public and protected members in a class file. This helps you see implicit code in the compiled class file. I'll bring up the Java P help page on Oracle's site. If I scroll down a bit, you can see all the options we can use on this tool. The only one I'll be demonstrating is P, which is short for private, and will show all members on a class regardless of the access modifiers. The default mode would only print the public and protected members. This tool can be useful with types like records and enums that do have quite a bit of implicit code. Let's play with this for just a minute. First, I need to identify where my class files are being created, and you might remember we talked about this when you were setting up IntelliJ. I'll expand the project panel and show you that my class files are generated in an out folder under the project folder. I'll continue to expand these folders and you'll see I have 3 files under the folder that matches my package structure. These are the compiled classes. What I'll do next is open a terminal session inside IntelliJ's IDE. I can do this by selecting the tab at the bottom of the screen where my output is displayed. I'll select Terminal there. Note that my terminal window is expanded to show more output. You may want to do the same by expanding the window in the usual way. I'm going to execute Java P from this shell using the argument -p, then specifying the location of the class file. I'm going to first show you the person class, which is my record. -p shows all classes and members, including private ones. Note that this path needs to exactly match the path we saw when I expanded the out folder earlier, including the right case for the project name. Note also that the // will work on all operating systems, including Windows. Running this now. You can see all the hidden implicit code that gets generated for us on a record. You can see the private final fields, first the name, then DOB. The next 2 statements are the constructors. The first is my custom constructor, but the second is the implicit canonical constructor. After that, there are the methods toString, hashcode, and equals, as well as the accessor methods. Okay, so you can see this output is helpful to understand what code is being implicitly generated by the compiler. If you don't get this output on your computer, but instead get an error about Java P not being recognized or found, it means that Java P is not in your computer's path and you need to add it. Or more specifically, the folder containing the Java P executable is not in the path. This is most likely a Windows issue, as in my testing, Mac and Linux will add the path automatically when the JDK is installed. The folder you want to add to the path is the bin subfolder in the Java development kit you installed way back in the early parts of this course. I'll open up Windows 11 settings here and type envir, which is short for environment, and choose Edit Environment Variables for your account at the bottom. Click Path and click Edit if you want to add the path. In my case, you can see I've already added the folder to my path, so I do not need to add it again. If you are adding the path, after initially clicking Edit, you click New and you can browse to the bin subfolder of the JDK installation folder and click OK to add it. Once done, close down Settings, and you will probably have to close down and start IntelliJ for the changes to take effect. Okay, so I'll close down Settings now, and I'll type Exit to close the terminal window. I'll also close the Out folder for now as well. I'm going to end this video here and discuss the enum and its constructors in the next video.